Hi everyone! Today we'll be creating a private S3 static website, delivering it securely with CloudFront and automating the entire deployment using GitHub Actions. This means that every time we update our website files in the GitHub repository, they'll automatically get published to our private S3 bucket and served through CloudFront. Let's get started. Today's project is inspired by a solution outlined in an AWS blog post. But before we dive into the technical steps, let's look at a real-life example to understand why this setup is so useful. Imagine your company has an internal documentation site for employees, like onboarding guides, project resources, or internal dashboards. Instead of manually uploading updates to an S3 bucket every time you make changes, GitHub Actions automates the entire process. For example, when the HR team updates an onboarding checklist or the engineering team updates API documentation, they simply push the new files to the GitHub repository. GitHub Actions automatically syncs those changes to the private S3 bucket, and CloudFront ensures the latest version is securely accessible to authorized users. This way, everyone always sees the most up-to-date content without manual intervention. Here's the architecture we'll build today. We'll connect our AWS account with GitHub using OpenID Connect (OIDC) and an IAM role with the appropriate permissions. Next, we'll push an index.html file to our GitHub repository. GitHub Actions will automatically copy that file into a private S3 bucket with static website hosting enabled. Finally, CloudFront will securely deliver the website to the outside world. First, we need to establish a trust between AWS and GitHub through OpenID Connect. Here's how. Sign into the AWS Management Console and open the IAM service. In the left navigation pane, select Identity Providers, click Add Provider, and configure the following settings. Provider type, OpenID Connect. Provider URL, .audience, sts.amazonws.com. Click Add Provider to save the configuration. This setup allows GitHub Actions to securely assume AWS roles without managing long-term access keys. You also need to assign a proper role to this identity provider, so let's click the identity provider name, and then click Assign Role, click Create a new role, Trust identity needs to be Web Identity, select your audience, provide your GitHub organization name. You can also give your GitHub repo name. Now click Next. For this example, I will upload S3 files, so I will give S3 full access permissions to my role. Finally, give your role a name and create your role. This role allows GitHub Actions to access S3 securely without relying on static credentials. Next, we'll configure GitHub Actions to automate our deployment. Create a GitHub repository that matches the one referenced in AWS IAM. In your GitHub repo, go to the Actions tab. Click Configure under Simple Workflow. This will automatically create a .github/workflows/blank.yml file. Rename blank.yml to main.yml, or create your own YAML workflow file. Add the following permissions and AWS credential setup in your workflow YAML. You can copy that from my GitHub repo in the description. Replace the AWS region and role to assume with from your resources within the main.yml file. Commit the changes, and let's see if GitHub can connect to my AWS resources. Connection is successful. You can also verify that by checking the event history from Cloud Trails. Now finally, let's update main.yml file so that it can upload the index.html file within our GitHub to an S3 bucket. For this action, you will need to add another item under the job given name. Given name. This one will run AWS S3 sync comment and will check root GitHub folder, and it will upload the files under the provided S3 bucket. I already had an S3 bucket with static website properties, which has a CloudFront distribution connection. Please go watch our previous video if you had any problem for that creation. So it will exclude all files and include only index.html file. Now commit the changes and upload your index.html file into the root folder. Now let's check our S3 bucket to see if that file is actually uploaded in our S3 bucket. Let's see if our CloudFront link is running the static website. As the final step, I will update my index.htm file under my GitHub repo and check if my CloudFront distribution link is working with the current update. As you can see, it works perfectly fine with that new updated index.html file. And that's it. We've successfully created a private S3 static website, automated the deployment with GitHub Actions, and securely delivered it using CloudFront. If you found this tutorial helpful, don't forget to like, subscribe, and hit the bell icon for more cloud tips. See you in the next one.